Perfect, got it going. So yesterday we learned how to do the reverse power rule, essentially. And I'm hoping you guys had a chance to try some of those. Today we're kind of just learning up little tidbits of information and various things. It's going to be really important that you guys will have had a chance to practice questions before tomorrow. So tomorrow we're going to learn what's substitution, so U substitution for integration. And if you haven't had a chance to practice like power rule and the different things we're learning today, it's going to make tomorrow's very difficult for you to learn. So I know some of you guys are behind. If that's the case, catch up obviously, but make sure you try some of the questions that we learned yesterday and today before tomorrow, because tomorrow is just not going to make any sense if you don't get a chance to practice them. So that's just kind of a forewarning. Okay, so today I thought we should start by talking about indefinite and definite integrals, because I don't know if I have specifically told you the difference between them yet or not. I know I've shown you both, and you might not even remotely have noticed the difference between them. I don't even know if I should call on somebody or if I should just start writing. This is basically the main difference. Indefinite integral is when you take integration and there are no numbers here. So your answer would be something plus c. A definite integral is when you integrate and you have numbers on the bottom and top. In that case, your answer is going to be a number. There is no plus c. So your answer will be the top number minus the bottom number plugged into the integrated answer. So these are the two styles of integrals you're going to see. And so if I haven't had a chance to, talk about the difference between them, do know that that's literally the only difference. So the methods that you use to integrate are exactly the same. So like for both of these, if you get a variable to a power, you use the reverse power rule. But if it's an indefinite integral where there's no numbers, you write the answer plus c. If it's a definite integral, you would do the power rule to get an answer, plug in the top number into the answer, minus plug in the bottom number into the answer. So that's essentially the difference between them. Now in Khan Academy, they actually have separate sections of homework for this. I 100% did not feel I should take like a whole day to teach power rule again on definite integrals. And we absolutely can do an example or something together, all that kind of stuff. But I did not feel the need to take a whole separate day for just talking about those differences. Okay, so here are some other antiderivative or integral properties. Not properties, rules, whatever you want to call them. If you are integrating 1 over x dx, if you are integrating e to the x dx. So we learned how to integrate reverse power rule yesterday, and that only works if you have a variable to a power. Definitely not every equation is going to be a variable to a power. So there are other things that we have to learn how to integrate. This is x to the negative 1 power. This is the one variable to a power we couldn't use power rule for. And the reason we can't, or shouldn't, whatever you want to say, Hopefully this isn't like a difficult question. It's not meant to be, but hopefully it's not. Sam? Sam, do you remember what 1 over x is the derivative of? Okay, tip your tongue. I get it. Close. You're not, I mean, it's not, but it's not a normal thing. Does anybody remember? Instead of me just like asking one person. Yes, Aiden. It's it's from natural logs. Yep. So what's going to happen is you get this. So if we took the derivative of natural logs, we would get 1 over x. And so if we are integrating 1 over x, that's basically like saying we are integrating the derivative answer. So that's where it's kind of helpful to try to remember like hierarchy of things. The part that may throw you off is the absolute value symbol. The absolute value symbol is there specifically because in the original problem, it doesn't say x has to be positive. But if you're using a natural log, x can't be negative. So the reason it has absolute value is just for that specific purpose, because it's some constraints that you wouldn't know ahead of time. Now, if this was a definite integral, let's say this said from 2 to 4. Instead of me writing plus c, what the notation would be is I would put a bar. Okay, it didn't draw it. I would put a bar at the end of this with a 4 and a 2. This is frequently how you'll see it in calc textbooks or other places. It's just weird notation. And then you would plug in the top number into your answer, minus plug in the bottom number. Theoretically, if you guys remember the properties of logarithms, this actually equals natural log of 4 divided by 2, which is natural log of 2. I don't really care about that for right now, but that was if you guys remember the properties. Okay, let's go to the second one. Oh, wait, take that back. I want to erase this. So I was just reminding how do you do a definite integral if you had it. If there were no numbers like this one didn't originally, you put a plus c. Okay, the integral of e to the x dx. If you guys remember, the derivative of e to the x was e to the x. So it works out quite slick that the integral of e to the x is e to the x. E to the x is basically the easy mode for calc because you get the same answers both ways. Okay, the next two are sine and cosine. Oh, that was a bad symbol. It's so hard to write nicely in this. Okay, trig integrals are really going to throw you off. I shouldn't say really throw you off. They're exactly backwards for sine and cosine. And that's because, like I'll do cosine first. If I'm integrating cosine of x, I'm trying to find what equation has a derivative that is cosine. And so if I take the derivative of positive sine, my answer would be positive cosine. And you guys will kind of remember that when you did derivatives, derivative of cosine was negative sine. So integrals and derivatives are going to be backwards for this. Integral of sine is negative cosine. Okay, now these four that we just went over, there's no, it's not like the power rule where you learn steps. These four, if you have this exact equation, that's the exact integral answer. And that's just kind of what you have to know for some of them, unfortunately. So let's do an example together that kind of uses parts of that. Let's do a problem. So find the integral of 2e to the x minus 3 over x plus 4 sine x dx. Now this dx is on the whole equation. It kind of bugs me sometimes that they don't put parentheses around this to show you that it's the whole thing. But this is frequently how you see it. They often don't put a parentheses because it's almost like they kind of assume that the integral symbol and the dx are parentheses. Okay, but let's figure out this answer. Jacob, do you remember what the property says when we have multiple terms? So like if you have plus and minus signs, what's the property for integration for terms? Perfect. That's a great way of saying it. Yes, you can integrate each term individually and separately. Okay, so I'm going to do 3 separate integrals. All right. First one, integral of 2e to the x. Ariana, do you have any thoughts on how to integrate 2e to the x? Okay, would you like me to help you a little bit? Okay, no problem. So what I'll start with is a multiplier of 2. What happens when you have a constant multiplier in integration? Correct. So the 2 has nothing to do with the integration. So I am only going to be integrating e to the x. And right before this in our notes, we talked about how to integrate e to the x. Perfect. Perfect. Oh, actually, that brings up a good point. I didn't even talk about that. So what you said was perfect, and that's great. We'll leave it as that. I'll put a plus c question mark. Okay. Minus sign. Alexandre, any thoughts on how to integrate 3 over x? Very close. Good logic though. So the over x part is kind of, I'm going to guess, where you were trying to come up with ln. Okay, so the 3 on the top is the same thing as saying 3 times 1 over x. So the integral of 1 over x is ln of absolute value of x. The 3 that was on the top would go in the front as a multiplier. So very good. The fact that we haven't even talked about these at all is pretty good that you just figured out ln out of it though. Okay, third term, 4 sine x. Kennedy? How about 4 sine x? Do you want me to guide you through it? Perfect. I'll put the negative in front of the 4, but yes. Absolutely, that is excellent job. Okay, so here's the weird part of this problem. And very good for those who answered, because we didn't talk about it at all. Is each one of these kind of individually has a plus c. Let me, kind of shorten this answer. So we have two options. We can write three different C values. And this would technically be correct. I will say that you'll never see this anywhere. So instead of writing three different C's, what's going to happen is they just join them all as one big C. And they combine all of the C's together. So the reason they do that is C is a number that you don't know, and you might be able to find out later. So let's do a pretend situation. Let's say C1 was 5, C2 was 3, C3 was 6. Well, instead of you saying plus 5, plus 3, plus 6, you could say plus 14. So instead of writing C values separately, you will traditionally see the C values combined. So that's the circled answer would be the answer that you'd see everywhere. Okay? Absolutely ask questions away if you have any. It's not a stupid question because it's kind of weird that we just randomly write plus a letter all the time. This is probably the only way I'll be able to explain it nicely. If I take the derivative of x cubed plus 5, I get 3x squared. Derivative of 5 is nothing. If I take the derivative of x cubed plus 2, I get 3x squared plus 0. Yeah, so when you're integrating, we're kind of going backwards to try to find out what it came from. And because the constant numbers would always cancel out in derivatives, we would never know if there was a number added or not. And so when we're integrating is going this direction, we put plus C because we don't know what the number should be. So we just write plus C. Yeah. And then later on, we're actually going to figure out how to figure out C. Nope, that's not a stupid question at all. So it is extremely helpful in Calc if you can understand where some of the details come from, because, well, the whole freaking class is made up of details. All right, let me put another question up. Okay. AJ? Do you have any thoughts on this one? Like, any ideas? Okay. So, actually what you said, which I should have thought of this immediately. The number one error on this problem, the number one error is somebody is going to integrate the top and then integrate the bottom separate. Because we go through all these integral properties, and it feels like one of the properties should be top and bottom are separate. But it's not true. So you can't integrate top and bottom separate. That would be the Go ahead. No. Yes. Yep. Absolutely. That is one method. Yep. So that is one of the two methods I was going to show. Nice job trying to come up with that, because a lot of people, when they look at this, kind of feel like there should be a quotient rule. And quotient rule only works for derivatives, and product rule only works for derivatives. There is no such thing as a quotient rule for integration, which kind of sucks. So if you have let me spell denominator. When a denominator is a monomial, so this specific situation, if the denominator is a monomial, you can divide it out or bring up and multiply it out. This only works if the denominator is a single thing. Okay, so I'll do AJ's method first, which I traditionally see that as the more popular method. It's not the method I learned, but it's the most popular method I see students prefer. And so this method is to bring x to the third up to the top as x negative 3. The second method is to split up the fraction, to divide it out. You'll get the exact same answer both ways. But I just wanted to point out that no matter which way you picture how to do this, it will work. So this only works if you have a fraction and the denominator is monomial. So the first one, if we distribute it out, we will get the integral of 5x to the negative 3 minus x squared times x to the negative 3. You add their powers. And I wanted to show it a couple different ways. Okay, so integrating 5x to the negative 3 isn't a big deal. You essentially add 1 to the power, because it's power rule, divide by the new power. But integrating x to the negative 1 is a big deal because you can't use power rule. If we integrate x to the negative 1 with power rule, you get to the 0 power divided by 0. Doesn't work. But we did just learn how to integrate this. And this is where it's disguised. Integral of 1 over x. If you want to put a little note by this in your notes, integral of 1 over x is the same thing as x to the negative 1. And they look like completely different problems. Whenever you get these within something you're working on, these two feel like they're totally different, even though they're the exact same thing. So if you have the integral of x to the negative 1, the answer is going to be ln of absolute value of x. And so I wanted to make sure to write it both ways for you so that you could see that. X to the negative 1. What most people do is they try to use the power rule, and then you get divided by 0 and realize something's wrong. So then hopefully that's going to be your cue to remember that it's natural log instead. Okay, how are we doing so far? Does somebody want me to answer anything on something I wrote up here? Okay. Go ahead. Yep, go ahead. So -1 is technically the only number you can't do power rule to. Because if you, it'd be divided by 0, yeah. Yeah, so, yeah, there's nothing wrong. If you try to do power rule, you'll probably remember that it doesn't work once you get divided by 0. Well, okay, I have 2 left that are, odd situations. So you'll see problems written like this sometimes. When the function itself is too annoying or complicated to write within the integral symbol, sometimes they'll write the function separately and then tell you to integrate the function. So this is one of those cases. It's been a little while since we talked about piece functions. So this is called a piece function or a piecewise function. I've seen both wordings. Piecewise always just sounds dumb to me, so I don't like saying that one. And if you guys remember what piece functions are, it's made up of pieces of multiple functions. And so in our case, if you're integrating, it's kind of a big deal because when you integrate, you have to integrate a function. So we got to figure this out because like a definite integral stands for the area under the curve. Well, according to this, we have 2 different curves in different places. So what you need to do is you need to match up your definite integral numbers with your boundaries. And you're going to break up, you're going to break up your integral to match up with these boundaries. So our first integral, because the boundary is at 0, and 0 is in between -2 and 2, that's the only reason this matters. So what I'm going to do is I'm going to say I'm going to have one integral be -2 to 0, and -2 to 0 would be the bottom one. So then I would say 3x squared minus 2x dx. Plus, so this was one of the properties from the other day, that you can break apart a definite integral into 2 smaller ones. So now we're going to have another one from 0 to 2, which is the top one, bigger than 0. And so we will have 2 separate problems. Do you guys feel comfortable enough trying to figure out this answer on your own yet? If I give you a couple minutes, do you think you could do this, or do we have to do it? Should we do it together? Does anybody want us to do it together straight away? Okay. Then you guys take 2-3 minutes. Try to find this answer, see how well you can do. So this is what you should have gotten on your own. If you integrate the first set of equations, you get x cubed divided by 3 reduces out the 3. X squared divided by 2 reduces out the 2. So you get x cubed minus x squared from negative 2 to 0. The second equation, you bring it up one power, so you get x squared divided by 2 turns into a 3. So you get 3x squared from 0 to 2. Now what I'm going to do is I'm going to plug in the top number first, which is actually quite easy. Ooh, look at it, I'm drawing emoji. Bottom number. So now I'm going to subtract to plug in the bottom number. So negative 2 cubed minus negative 2 squared plus the second integral, definite integral. And I'm going to plug in the 2 first. So that'd be 3 times 2 squared minus, plug in 0. All right, so 0 minus 0 is 0. Minus. This is negative 8 minus positive 4. So 0 minus negative 12 plus 12 minus 0. So 0 plus 12 plus 12. Your final answer should be 24. How did we do on that one? I don't really have a good way of asking this one without having your name associated to it. No. Just for the x. Yep. The only reason I chose 0 is because 0 was the boundary for that piece function. So it's not always going to be 0. That this number could be anything. And so if this number is in between the definite integral that you were being asked about, then you have to split it up. Yeah. If for some reason you are asked in only one of the sections, so let's say we asked for the integral from 3 to 8, then we would only use the one section. So then in that case, then we would say the integral from 3 to 8 of, oh god, that's bad 8. 3 to 8 of just 6x. And then we would keep it just one equation. So the only reason I split it up was 0 was between the two boundaries. Between the negative, oh yeah, that's where it was. 0 was in between negative 2 and 2. And then it kind of required me to use two different equations. Oh, you know what? I might regret showing this to you. And I'm not sure if this is going to come up on the recording. Oh my god, why is that so goofy? How do I make it smaller? Let's make it bigger and then smaller. Okay. This thing is going crazy. I don't even know what to do with this. Can you guys can't even see the calculator, I suppose, can you? Maybe I will do this tomorrow on the school computer, because the school Macintosh computer, or the Apple computer, I've got the actual Texas Instruments calculator on there that works a million times better. So you can do these on the calculator. Definite integrals your calculator can do. Because when your answer is going to be a number, your calculator can work it. If your answer is going to be an equation, then your calculator can't. So you can always check this work in your calculator. Okay, last problem, and then you guys should have enough info to go on. So we are asked to find the area under the curve from 0 to 4 of the absolute value of 2x minus 6. So these aren't hard, but a lot of students have trouble with them every year. And so I want to take a little bit of time. I don't want to go fast through it. Lauren, is there anything about absolute value equations you can tell me you remember about? Like the graphs? Because I think you learned the parent function in pre-calc and Algebra 2. Yes. Yes. Perfect. Okay, so it's technically only going to be a V shape if the original graph was a straight line. So if you are graphing an absolute value, if your graph is a straight line, anything that was negative gets flipped up to be positive. So it usually looks like a V. Well, that only applies if it was a straight line. If for some reason you had a parabola, anything that was negative gets flipped positive. And so it looks, it ends up having sharp points. So, Lauren, for this one, you were perfectly correct. It's going to be a straight line, or a V, because this one is a straight line to start with. I'll graph old school way here. Y-intercept of -6, slope of 2. And negative parts get flipped up like that. Chidera, my question to you, how do I know the x value where my absolute value equation turns around? How do I know that spot? Okay, what would that do? Oh, then where'd you get 4 from? Oh. We actually haven't even talked about the integral part yet. Didn't even think of that. Cameron, do you know how we figure out this location right here where the tip of the V is? Okay. I'll just ask anybody rather than just calling on individual people, maybe. Close. You and Chase had the same idea. Backwards. So if I plug in 0 for x, I would find the y-intercept. I need to put 0 in place of y. Or, this is called the x-intercept. So the x-intercept is where your graph is going to turn around or flip backwards. So what I'm going to do is I'm going to take my equation that I had and make it equal to 0. So you guys had the right idea. You put 0 in place of y. But I'm not using the absolute value symbol because I'm trying to figure out the location where it will flip. So once you solve that, in this case we get 3. That tells me that x equals 3 so this gives me an x equals 3 for my x-intercept. Now I'm going to talk about my integral. My integral is from 0 to 4. Is my x-intercept within that 0 to 4? That's kind of what you're going to ask yourself, right? So I know that I am trying to find the area under the curve from 0 to 4. And because I just found out that x equals 3 is in between 0 to 4, then I know that my graph is made up of 2 separate lines. That one and that one. And x equals 3 is where they switch. So x equals 3 is what I need to do. I'm going to break this up into 2 integrals because my x-intercept was in between my boundaries. Now here's the next part. The next part is, how do I know what equation to write there? Well, maybe let's look at this. Let's look at this section right here in orange. That section was on the original line that I drew. So that section was on the normal equation, 2x minus 6. This green section is the opposite of the bottom part. So this green section is the opposite of 2x minus 6. And so that's how I'm going to come up with the equations. From 0 to 3, it's the opposite. I'll put a negative out front of 2x minus 6. The second section is just 2x minus 6. And this is how I'm going to approach absolute value questions. And then I actually have to integrate and do work. So integral of 2x is x squared. Integral of 6 is 6x. I'm going to make it a plus 6x because of this minus sign. And this is from 0 to 3. This is x squared minus 6x from 3 to 4. Plug in 3 first. Negative 9 plus 18 minus, plug in 0. Negative 0 plus 0. Plus the second one. I can scroll up in a second. Yep. So I'm going to plug in 4. And then I'm going to plug in 3. I am purposely trying to show you the way that I'm writing these in parentheses and things like that, because you guys are going to have to be very careful where you're going to make mistakes with negative signs. And I see it quite often, so I'm trying to purposely show you how to write it out slowly, organized. So negative 9 and 18 is 9 minus 0 plus negative 8 minus negative 9. Let's see if I put all those together. 9 minus 8 is 1, plus 9 is 10. So that is telling me that the area under the curve, which I know this graph is a mess by now, the area under the curve would be 10. Is this where you wanted me to scroll up to? Probably. Okay. Okay, how are you guys feeling about today? Because I'm done showing you various things today. On a scale of 0 to 5, how are you feeling about the problems today? Why is there a negative sign in front of 2x minus 6? There's a negative sign in front of the 2x minus 6 because this green line, oh, I already screwed that up. This green line is the opposite of 2x minus 6. So 2x minus 6 is down here, but we flipped it up top to make it positive because of the absolute value. So it's the opposite of it. Okay, I kind of expected a lot of 3s, to be honest. And it partially is because this is... A lot of people like Power Rule because there's steps involved, and so you can follow these same steps all the time. Today's types of problems leave you feeling a little nervous because, you know, they're all different, and that's usually what makes people feel quite nervous about them. And the fact is, you have to do examples and practice some to be able to figure out, you know, what's going on. So if you are worried that you feel like you have a 3, you know, you're at a knowledge of 3 right now. It's not a bad thing. So I guess I would wait to see practicing the homework tonight to see how well things go. I did list the assignments in Schoology that you should try tonight. I can't remember what they're called off the top of my head. I want to say there's like 4 of them or something, maybe 5. I know the last assignment is quiz 4. So basically do all the assignments up to quiz 4. And I did get definitive yesterday. So I heard quite a few people say that if you have all of the mastery points possible before the quiz on a topic, it'll pop up with a message for you saying that you can't increase your mastery percentage anymore. Because it sounds like the quiz will only increase your mastery percentage to 2 bars. The end of unit test will increase it to 3 bars. So if you're in that situation where the quiz isn't going to benefit you, you're welcome to take it if you want, but you 100% don't need to. The quizzes basically are just there to help you increase your score if you need it, I guess, or to see where you're at. I'm just going by the score total at the end of the unit, so it doesn't matter to me if it's optional. You know, if it tells you it's optional, it's fine if you skip it. But either way, you should be all the way up to quiz 4. It is really important that you guys try some of the questions from yesterday and today before tomorrow, because tomorrow is going to feel difficult if you don't try any. Okay, there we go. I ended up talking for 50 minutes on random things. All right, I appreciate you guys coming today. I will see you tomorrow. Make sure you guys try some questions though.